For airfoil, the contribution of viscous effect, because you have tangential and the normal, right, force, and then both of them contribute to the lift. But most of the time, the contribution of the tangential, which is considered the shear stress, is minimum, bare minimum, because this one is at the bottom, right? When you have this, then it will provide force on that direction and that direction. Okay, so it lifts. But this tangential portion is negligible compared to the pressure, because the pressure is the one that we get from the different shape, right? So most of the time, the lift due to shear is minimum, but the drag due to shear is the maximum one. Okay, the drag due to pressure is negligible because the profile is relatively slender. Slender means it has a smaller head but bigger length, right? If you tell your friend has a slender profile, which means he is tall or she is tall but having a skinny body, that one is slender. Okay. Yeah, Tom Salamander, slender. Okay, so that is slender. Okay. Okay, so now again coming back to here, to make your aircraft fly, okay, you need to have the FL equal to the weight of the aircraft, right? If your weight is higher than the FL, your aircraft will not take off from the ground. If it is higher, then you will start to have lifting, so you will make it airborne. But now, the problem is, when you design a wing, you do not want the area to be very big. Okay? If you follow the history of airplane, we used to have not monoplane, but we have triplane and biplane. The reason is because at that time we cannot have a good CL, so we need to have more wing area. If you need to have more wing area, you cannot have only one plane, but you need to have a more wing like this one. Okay, this is B plane. Sometimes you have a 3 plane. Like that. Yeah. Why it has 3 wings? Because at that time we cannot have this one higher, CL. Our CL at that time we have no technology to make the CL bigger, and the engine at that time cannot provide you the required velocity. So the velocity will be very slow. Because the velocity is slow, your CL is low, the only thing you can do is to increase the wing, right? The area of the wing, but you cannot put the wing on all of your aircraft, right? So that's why they make it stack it up. Okay, so you have these 3 wings and 2 wings, right? But you will not say 2-wing aircraft. They call it biplane and triplane. Okay. But nowadays, we rarely see this kind of aircraft, right? Most of the time we will see a monoplane aircraft. Okay. Monoplane, turboprop or turbo. Okay. So now, if you know that your W has to be equal to FL, or rather your FL has to be equal to W, you cannot have too big area of the wing. You cannot change the rho. Rho is the nature condition, you cannot change it. The only thing you can change is the CL and velocity. Right? So this one, you want it to be as small as possible. Okay, this morning in the tutorial I told you that. Okay, this is a very, very simple illustration. Usually when you have an aircraft, your aircraft is there. Assume this one is aircraft. Assume it. Looks like A bird. Start. Okay. When you take off, usually in the tip of the runway or at the edge of the runway, your V0 will be 0. Okay. Right? Usually you heard the pilot says, aircrew be seated.
Ready to take off.
Ready to take off. Right? Because you already there seated. You already there seated and your seatbelt has been fastened. But the flight attendant usually still doing that. Right? And then some of them they bring the counter. You see, click, 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 click. Right? They do that during the taxi. Okay. So during the takeoff, just prior to takeoff, they will say that, and then they will be seated. So you know that the velocity is 0. Now, if you are observant, you know that the takeoff will take you about 50 seconds to 60 seconds depending on the size of the aircraft. So the 60 seconds, maybe it will take off from here. So this one will take 60 seconds. Right? In this, you will read some velocity. Right? Some velocity. We do not know, but some velocity will be there. Because the velocity here will be V0 plus 80. So depending on the acceleration provided by your engine, you will need this time or even longer time. Right? But that one depend on the density and some other parameters, the CL. Okay? So now, if you want to increase the velocity, let's say you cannot build the aircraft that can take off at 60 meters per second. You need it to be at 70 meters per second. This is the minimum takeoff. So what happened? What is the consequence? You need a longer runway. That's why you want to design an aircraft that can take off at a minimum speed. Right? And the good thing about having an aircraft that can fly at minimum speed is that if you need to abort, sometimes you need to abort the flight. You need to cancel the takeoff. You still have time to brake, to stop. Because there is a point where you cannot cancel the takeoff. You have to go up, then make a U-turn, goes down again. Okay, because if you stop at that speed, the only thing happen to you is you will end up crashing on that.
You will end up dying.
Right? So you need to make it as small as possible. Right? So to make it as small as possible, you need to make this one big or that one big. Okay? One way to do that, so if you want to maximizing this, the only way to do that is by installing a flaps, a slot, and you control the boundary layer. Right? That's why sometimes Prandtl is called the father of aeronautic. Prandtl, the one that give you headache with the boundary layer, is actually considered as the founder of aeronautic industry because he's the one who found that boundary layer concept. And you know all those airplanes, the most significant development is usually occurred during the war. When you have a war, right, they want to defeat the enemy, and then there is where the technology is advancing most of the time. Okay? Your handphone on the 90s, it used to be only those spy can have it. Right? Those phones that you have now is actually a very old technology. They already use it sometime before. Okay? Nowadays, maybe if you see a flies or butterfly nearby you, you never know whether it is a real butterfly or it is a robot. Right? You never know. So be careful.